you have questions?
Thanks, Chris. So a lot of information there in a short time. We can take a couple of questions. Anybody have some burning questions you'd like to raise? Anyone? Yes?
Have you seen any, besides those big cloud vendors you mentioned, have you seen any what's been referred to now as the enterprise cloud vendors?
Yeah, so the question is, what have I seen from the enterprise cloud vendors? The two companies that spring most to mind are RightScale and Cycle Computing. Both of them aren't quite in the same realm of people who are offering to cloud enable your entire data center. I think the people who are offering to cloud enable your data center are probably a year or two ahead on the hype curve. Like I don't see replicating AWS inside my data center, but RightScale has some really good practices for moving stuff onto the cloud and managing it. And Cycle Computing is another sort of company that sprung up in this utility computing ecosystem where they've got tools for both bridging your own internal clouds with an external cloud or moving that stuff internally. So, in terms of company names, the sort of real stuff that I've looked at and used, it would be Cycle and RightScale. Question there.
Chris, have you seen anyone experiment at the moment with a solid-state storage?
Yeah, I think for solid-state storage, one of the really interesting things about it is that you're starting to find storage products on the market where you can actually mix and match storage stuff. One of the cooler things about Sun's Amber Road is that you can actually have write-optimized or read-optimized solid-state storage. Where I typically see it is the solid-state stuff for large-scale data processing, almost log file stuff, or maybe the genome map, the sort of mapping and assembly type stuff. Right now, for me, solid-state stuff is a little bit too spendy. It's still very, very expensive. I would say it's not mainstream. It's very, very niche, and it would be for very, very heavily read-optimized workflows.
Real quick, go ahead. It's not even overlap. The physics people put us to shame. Our IT and our data problems are nothing compared to the big science particle people. The problem that I have with the physics, I don't want to say I have a problem with the physics community. The problem that you're going to run into is that the physics community, I lump them in with large collections of scientific organizations that are successful because they're funded with sovereign dollars. And let's put it this way: the physics people are solving their problems because they have budgets of hundreds of millions of dollars. And it's very, very, and it's the same thing why I'm cynical about grid computing. The only people who are successful with grid computing were nationally funded supercomputing sites or big universities. These are people with six-figure, 7, 8, 10-figure IT budgets. So let's put it this way. We can learn a lot of lessons from the physics community. The hard part is that the physics community is coming from a budgeting and financial and sort of national sovereign nation backing that we typically don't have. I don't have a $200 million budget to solve my storage dilemma, and that's really the issue that we have. Yep.
They also seem to be better than we are at deciding on common data models.
Scientists are not good with standards, and I would say actually even IT is not good with standards. But you're right, definitely.
I'd like to thank Chris again.
Cool.
Very nice presentation.
Thank you very much.
We do have one announcement. There's going to be a reception down in the exhibit area sponsored by Merck.